All right, let's dive in. Today, we're basically going to build an artificial mind from scratch. We're going to explore the absolute fundamentals of AI, how it actually finds answers, and more importantly, how it makes decisions when the world is messy and uncertain. So let's get to it and build our AI one logical piece at a time. It all really boils down to this one huge question. When you see an AI playing chess or helping a doctor or driving a car, what is really going on in there? Well, spoiler alert, it's not magic. It's a series of brilliant, logical steps, and we're about to trace them right from the very beginning.
So, here's the game plan. First, we've got to define what we even mean by intelligence. Then, we'll meet our star player, the intelligent agent. After that, we'll teach it how to search for solutions, help it deal with the messiness of the real world, and finally, we'll give it the power of probability to make some seriously smart decisions.
Okay, first things first. We hear the term AI thrown around everywhere, right? But what are we actually talking about? Let's nail down a solid definition. At its heart, this is the whole point. AI is all about making machines do stuff that, if a person did it, you'd say, wow, that requires some intelligence. And we're not just talking about number crunching here. We're talking about perceiving the world, reasoning, learning, really simulating our own cognitive toolkit.
And this is where it gets really interesting. Think about it. Our human intelligence is often intuitive, a little emotional, and we're amazing at adapting to totally new situations. Machine intelligence, on the other hand, well, that's a different beast. It's unbelievably logical, incredibly precise, and it can chew through data for a very specific task like nothing else. The real quest for AI is trying to get a little bit of our messy, adaptive spark into that logical, precise machine. So, how does an AI actually do anything? Well, for that, we need to talk about the intelligent agent. You can think of this as the main character, the hero, in any AI story.
Okay, let's break that down because it sounds a bit technical. An agent sees its world with sensors. Think of a self-driving car's cameras. It then acts on that world with actuators. That's the car's steering wheel. And the whole thing is driven by a goal, whether that goal is get to the coffee shop safely or just keep the house at a comfy 70 degrees. And this loop you see here? This is basically the agent's entire existence. It's a constant cycle. Perceive, think, act. It senses what's going on, figures out the best possible move, and then it does it. This simple little loop is the heartbeat that powers everything from a little robot vacuum to the most complex AI on Earth. Okay, so our agent can see and it can act. But that think part, how does it actually decide what to do? The first, and maybe the most fundamental tool it has, is something called search. Now, when I say search, I don't mean typing something into a search engine. In AI, search is this methodical process of exploring a huge maze of possibilities to find a path to the goal. Like when your GPS finds the fastest route. It's not just guessing, it's literally searching through a massive web of potential roads to find that one perfect path. That's the challenge we're talking about. And there are basically two ways an agent can go about this. The first is uninformed search, which is just brute force. It's like trying to solve a maze by just keeping one hand on the wall. Yeah, you'll get out eventually, but it could take ages. Heuristic search, though, is way smarter. It uses a kind of educated guess, or rule of thumb, like, hey, let's generally head in the direction of the exit. It helps find the answer way, way faster. But what happens when the maze isn't static? What if the walls are moving and the environment is actively trying to stop you? That's where adversarial search comes in. It's built for things like chess or other games, where your agent has to think about an opponent who is also searching for their best move. The way it does this is with this brilliantly paranoid little strategy. For every move the AI thinks about making, it asks itself, okay, what's the absolute worst thing my opponent can do to me in response? That's the minimize part. Then it picks the move that puts it in the best possible spot, even after that worst-case scenario happens. That's the maximize part. It's why playing against a game AI can feel so brutal. It's literally programmed to assume you're a genius trying to crush it at every turn. So up until now, our agent has been living in a nice, neat world with perfect rules, like a chessboard where you can see every piece. But the real world, it's not a board game. It's messy, it's unpredictable, and tons of information is hidden. And that's the next huge hurdle for AI. Exactly. What's a medical AI supposed to do when a patient's symptoms could point to 5 different diseases? What's a self-driving car supposed to do when a camera sensor is just a little bit blurry? It can't just follow simple rules anymore. It has to learn to think in shades of gray. It has to learn to think in probabilities. And this right here is the answer. Instead of dealing in absolute certainties, like this is 100% an apple, the agent starts dealing in likelihoods. There's a 70% chance this is an apple and a 30% chance it's a pear. This lets the AI make the smartest possible decision with the clues it has, even when those clues are fuzzy. We're basically teaching the machine how to make a highly educated guess. This jump into probability is what turns AI from just a simple game player into a really sophisticated tool that can actually handle the real world. So let's see how it uses these powers. Now, a key tool here is something called a Bayesian network. I know, it sounds super complicated, but just think of it like one of those detective cork boards with strings connecting clues. A line connects "the ground is wet" to "it probably rained." But another line connects "the sprinkler was on" to "the ground is wet." A Bayesian network helps the OI weigh those connections. If it sees the sun is out, that rain connection gets weaker and the sprinkler connection gets a lot stronger. It's always updating its beliefs as new evidence rolls in. And this is why this stuff matters so much. This kind of probabilistic reasoning is already working all around us. When your email kicks a message to the spam folder, it's because it's calculating the probability that an email with certain words is junk. When an AI helps a doctor with a diagnosis, it's weighing the odds of different illnesses based on all the symptoms. It's how AI makes sense of our very complicated world.
So, there you have it. We went from simple rules to an intelligent agent navigating this huge sea of possibilities, and finally to a machine that can actually reason with uncertainty. This journey is the foundational story of AI. It really makes you stop and wonder, now that AI is getting a handle on uncertainty, what truly unpredictable challenges is it going to help us solve next?